Alright, number 36 says the graph below represents what kind of function? We've looked at all of these. I'm not sure if we've graphed an absolute value function, but we've looked at all of these today. So before today. So we should have a good idea of what each one looks like. But let's just run through a few sketches of each one. So linear function would be the first one that people would recognize, and that's going to be some kind of line. Okay, and so we talked about all kinds of lines, all kinds of slopes. This is not a line, so I'm going to cross off a linear function. I also feel like we should have a pretty strong understanding of what a quadratic function looks like. Quadratic functions mean they have x squareds in them, and they make parabolas. So that would be one of these two shapes. And that is not what that looks like, so I'm going to also cross out D as well. Okay. So I have two choices left, absolute value function or exponential function. Okay. Well, an absolute value function would look something like this. Y equals the absolute value of x. And an exponential function would be something like y equals some number, let's just say 2 for right now, raised to the x power. Okay. So these are my two choices. And I could get kind of a feeling of what these might look like by making a table just really quick. So if I did a table for the absolute value function, if I plugged in 0, the absolute value of 0 is 0. If I plugged in 1, I would get 1. If I plugged in negative 1, I'd also get 1. If I put in negative 2, the absolute value of negative 2 is 2. And the absolute value of regular 2 is 2. Okay. And if you graph that, just a quick sketch of the graph here, 0, 0 would be here, 1, 1 would be here, 2, 2 would be here, negative 1 would be here, and negative 2, 2 would be here. So it looks like I almost have this V shape, and that's what all absolute value functions look like. So absolute value function would make a V shape. This is not a V shape. This is not an absolute value function. Okay. This is in fact an exponential function, and you could graph that as well. We talked about exponential functions. They grow really fast. They also have asymptotes, little boundaries that they can't go beneath. So this line will just keep getting closer and closer to 2, and this side will grow exponentially, which is why it's called exponential growth. With this variable in the exponent, our numbers get very large very quickly, which you'd find out if you plug them in. 2 to the 0 power, anything to the 0 power is 1. 2 to the first power is 2, but then it would go up pretty quickly. 2 squared would be 4. 2 to the third power is 8. 2 to the fourth power is 16, and we're getting this really, really quick increase. So it would look something like what we see on the graph. So B is the correct answer.